Okay, so today for this week, we're looking at circles and arcs, and right now we're going to focus on how we can find certain measures of arcs. So arcs are usually measured in degrees, just like what we see right over for this example and this example. And there's different ways that we can use to find measure of minor arcs and measure of major arcs. So when we're trying to find the measure of minor arcs, a minor arc, or the smaller arc right over here, it's whatever the central angle is. So say this is 50, your minor arc will also be 50 degrees. Now let's look at a major arc. So what they mean is, so just a review from the other day, your circle is made up of semicircles, minor arcs, major arcs. The smaller section is a minor, the bigger section is what we call major. Now, since the entire measure of a circle is 360 degrees, right? We're just going to find a difference between that total and the minor arc. So when you subtract those two, the total number of degrees minus the 50 degrees, this is going to be your new measure of the major arc. So let's scroll down to an example. Wait, hold on a sec. Okay, so an example right over here is, okay, so say we have this circle, P, where RT is the diameter, right? So what we mean by the diameter is that whole line that is cutting the circle in half. Now we have to find the measure of RS. So we're actually looking at the measure of this arc right over here, right? So just like what we learned from that theorem before, is that if you have your central angle, your arc is going to be the same length. So if your angle, let's say the measure of angle, hold on a sec. The measure of angle RPS is going to be the same as the measure of arc RS. So if it's 110, that will also be 110. Now let's look at this one over here, the measure of RTS. What we mean by RTS is this right over here, RTS. So from here, in a circle, it's the rest of the part of the circle. So whatever I marked as yellow, that's going to be my minor arc. And so the rest, the green, that's going to be my major arc. So if I was going to write this down, the measure of RTS is going to equal 360. That's the total degrees of a circle. That's the total measure of a circle. Minus the measure of RS, which we know is 110. So if we substitute everything, 360 minus 110 degrees, you're going to end up with 250 degrees. So this one over here will be 250. 150 degrees. Now, this is kind of tricky. We have to find the measure of Rst. So to find the measure of Rst, it looks like we're trying to find the semicircle. So let's look at this carefully. To find this, we just have to remember that a semicircle is half of a circle, right? So let me just write that down. Semicircle is half of a circle. So if your total number of degrees is 360, half of 360 will be 180. So this one will be 180. Right? And notice how it's really important how I'm naming these arcs, because you see we have the same letters, the R, the S, and T show up, but because they're arranged in a different way, my arcs are going to look different. So this green arc is a lot different from this pinkish arc. All right, so let's scroll back up. So now we have this one. This is an arc addition postulate. So this is basically saying, like, you can find the measure of an arc if you're adding up two adjacent arcs. So if you have the measure of A, B, C, the red arc and the blue arc, they're next to each other or adjacent, and they also make up the whole ABC arc. So you can just break it up. You can add the measure of AB plus BC, and you are going to get the full measure of that whole major arc. So let's look at an example of this. So let's look at this diagram. So we have to find the measure of each arc, and we're using this circle right over here. So let's see. We have to find the measure of GE. So if we're trying to find the measure of GE, you're going from here to there. Okay? Now, just looking at GE, I noticed that GE is made up of GH. It's made up of GH, and it's also made up of HE, and that they're next to each other, right? So let's find the arc lengths of GH and HE. So since this is 40, this will also be 40. I'll just write like this. Since this is 80, this will be 80. And if I was going to find this one, A, so the measure of GE is equal to the measure of GH plus the measure of HE. And if you add those two together, you're going to get 40 plus 80. And that's going to give you 120 degrees. So this will be 120 degrees. Now let's look at this arc. We're trying to find GEF. So we're trying to find GEF. So we notice here, instead of being made up of two arcs, we have three arcs, right? So let's find the arc length of EF. So over here, since this is 110, EF will also be 110. And then I can just start adding them together. So the measure of GEF, that's going to be, wait, hold on a second. That's the measure of GH plus HE plus EF. So you're doing 40 plus 80 plus 110. 120 plus 110. And this will be 230 degrees. Okay. All right, so that's that. Now we have to find GF. So for finding GF, okay, so we're starting from G and you're going straight down to F. So it'll look like this right over here. So I'm trying to find the remainder of this circle, right? I already know that this green arc, GEF, is 230. So now I'm trying to find this one right over here. So using the ideas that we were introduced before, I'm just going to find a difference between these guys. So I know that the total number of degrees in my circle is 360 degrees. And I'm going to subtract that from GEF. So you're doing 360 degrees minus 230 degrees. And you're going to end up with 130 degrees. So this one will be 130, right? So that is how we are finding these angle measures.